actually edits the Nissan model we talked together regarding a training or something we can create in PiXYZ. The Nissan concept car. I see there is some message in the conversation. I don't know. I let you add checking everything.
Yeah,
it's not a big
deal. Problem. It just so there. I did miss a note from Frank. Will removing holes work better on meshes with higher detail before reducing detail? In other words, if you want to remove holes, is it better to do that before you decimate or after you decimate?
No. So far the holes removal in PiXYZ is working based on the CAD information, so the patches. And as long as you keep the patches, the level of the tessellation is not relevant because we are using the CAD information to remove the features, the holes in this case.
Okay. Perfect. All right. And then all the other questions had to do with just, when did the meeting start? Is the recording available? So we'll get, for everyone, the recording will be available. So anyone who missed part of this can go back and watch the beginning.
Okay, great. So here, let's do this. This is a complete workflow we made with Nighton. And it's an interesting one. There are small tricks that PiXYZ is very helpful. So we have the model, it's wire. So again, in PiXYZ, we made the choice to display the NURBS directly when you import a CAD file into PiXYZ. I know that can be confusing sometimes. Maybe 5% of PiXYZ users call us and say, hey, I don't understand. I drop my CAD files into PiXYZ and I can't see any polygons. So that's because when you load a native CAD file into PiXYZ, you'll see directly the NURBS or the BREPs here. So that means directly the conception lines coming from CATIA or Alias here in this case. But it's very interesting because by displaying the CADs and handling the CAD directly in PiXYZ, we can start working and optimizing the model on the CAD level. So let's this time use the CAD feature here. So I'm going to use first the repair CAD, which should be usually the first step you want to use in PiXYZ if you are dealing with a native CAD file. So we still have these famous blue lines here. So it's the exact same issue as we had with the tessellated model before. That means that all the patches here, all the small squares defining my geometries and my surfaces, because Alias is creating surfacic models. So all the surfaces here are disconnected. It looks like it's a standard issue with Alias. Anytime you export a wire file coming out of Alias, you will get blue lines everywhere. So you will get disconnected patches all the time. So the borders here are not connected together, and that's not good. Just like for the tessellated object, that means that you won't be able to create polygon across these borders. And so the tessellation creation won't be optimal. So let's use the repair CAD on this one. Same as the repair mesh, we are checking the connection between patches, we are checking the orientation, everything during the reparation process. But this time it's being applied at the CAD level, not at the polygonal level. So you can see most of the blue lines are now gone, and yeah, we repaired basically our model. So it may remain some of them. That's normal. Sometimes the meshes are just completely separate. It's two different parts. I don't know if you can see it quite good here, but you have one here in the middle, which is basically cutting the car in half. This here. That's normal. Maybe some of you know that, but in the automotive industry, when you are designing a car, sometimes you are only designing the left side of the car, not both sides. And afterwards, you just create a symmetry of your left model to create the right one, the right side. So that means that's why we here have a completely cut-in model. So this one can be repaired like the others. Perfect. So now the model is repaired, and we can create a tessellation. So that's really the basic workflow for creating, for generating, sorry, a tessellated object, so a model you can use in Unity based on the CAD.